All right. Welcome to the breakout room session, and I'm super excited to hear from Kieran and Chris on advancing AI and cybersecurity with Databricks and Deloitte. And I'll hand it off to them.
Okay, great. Thanks. You got to stay on your side. I'm going to take this one. Thanks everybody for joining us today. Appreciate you spending the time. So we're going to talk a little bit about a couple of trends we've seen in the industry over the last few years, starting with the fact that SIEMs have, in many cases, certainly traditional SIEMs, have somewhat hit kind of the strain of their life cycle, meaning people started dumping more and more data into their SIEM over time, and eventually that's led to excessive costs as well as some performance issues and other challenges in getting SIEMs to perform all of the analytics that we want them to do. You add to that the world of AI and a lot of the desires to use AI to do more advanced use cases in, around, and on top of SIEM. And the volumes of data are simply increasing, right? The processing going along with it is also increasing as you consider trying to use more telemetry in your environment to get at some of these advanced use cases. So along those lines, we've been thinking about, well, if the data is going to continue to expand and SIEM is still playing a particular role, how do we make for a more flexible and agile architecture? And that's kind of what we're going to talk about today, right? So just a quick intro before I get into the slide. So Kieran, obviously, been with Deloitte for quite some time. I am the cyber AI leader for Deloitte in the US. And so in that role, I spend 50% of my time working on solutions that we're taking to market. And the other 50% of my time I spend on building solutions internally for Deloitte to basically transform the way we deliver services to clients. And so I've got kind of the builder and the buyer hat, which is helpful. I've been in the IT space for about 30 years, cyber for more than 20, and so I've certainly seen a little water under the bridge and somewhat have the gray hair to prove it. Chris, do you want to introduce yourself real quick?
Yeah, thanks, Kieran. I'm Chris Nackstead. I'm a managing director with Deloitte. I work within Kieran's team to build and implement big data and analytics solutions for our clients, to include a lot of solutions that are now being built upon some of the new trends and applications in artificial intelligence. By way of my background, very similar to Kieran, 20 years in technology, 10 in cybersecurity. Through my work with Deloitte, I've implemented most of the SIEM systems that have been on the market for the last decade, and continue to work with a lot of these new products that are now hitting the market. I'm sure many of the folks that are here, if you do work in the SIEM market, you've seen just this explosion in the technology space around here, and a lot of the new technologies that are hitting the market, and a lot of the new approaches that are now coming to market with regards to building additional capabilities on the back of SIEM, whether it be within the new capabilities that these SIEM systems are offering on board, as well as augmenting them with other general purpose data and analytics platforms. And that's really what we want to be able to present to you today is how we're seeing the market adopting these general purpose data and analytics platforms, Databricks being one of the ones that we're seeing in the market a lot, and how they're using that to augment the capabilities of the traditional SIEM system.
Yeah, so and we'll be kind of going back and forth during the course of the session. We'll also leave time at the end for questions. A quick show of hands, how many of the folks in the room are actually in cyber in one form or another? Okay. What about data science? Okay, about a 50-50 split there. Developers, infrastructure, other, okay, there we go. All right, got a few there too. All right, so we'll try and tailor it to the crowd. So go ahead and flip a slide, Chris. So I won't talk through these because I know you guys are probably familiar with a lot of this, right? And there's 1,000 things that have gone on that make cyber harder. The way I summarize it is I've been in the business for more than 20 years. I'm not sure as an industry we're better off today than we were 20 years ago, because we're still doing the same stuff. We're still running around and patching systems. We're still looking at vulnerabilities, trying to know where our assets are, et cetera. So a lot of people look at AI and say, and the data requirements for AI, and they think about, well, how are we going to manage to use that? How are we not going to create more vulnerabilities in the system, et cetera? And the reality is the only way we're going to do better is to fight fire with fire. So you're going to have to use AI in the cyber function in order to be competitive with the advancing threats that's coming at the enterprise. right? Part of that message is also you can secure those systems, obviously, leveraging cyber as the business enabler of adoption of AI. But that's a different talk, and if you have interest in that space, happy to chat afterwards. So as we think about kind of where we're trying to go, we're anticipating that we have both sort of advancing threats as well as advancing needs, right? And the advancing needs is what sort of outrun the architecture that we've traditionally used, okay? So you want to hit the next slide? Mm-hmm. So there are, probably a few use cases we see clients most interested as it comes to leveraging AI in the business of cyber. The first one is threat detection and response, right? And that's what we're going to talk about today. But just to kind of give you a perspective on where the industry is headed, I'd say the second probably top priority is security compliance optimization. A lot of people focused on that. Third area would be attack surface management, right? The whole config, patch, asset, end-to-end process. And then secure software development, right? And incorporating this into the secure software development lifecycle. All that's going to require a large amount of data and beyond the telemetry we've historically used, right? So let's talk specifically about AI and security operations. So you can see these are the statistics from a recent study where they asked a number of professionals as to where they think they can leverage AI to make advancements from a threat detection and response perspective. Not surprisingly, improving detection of new or unknown threats came out number one. Obviously, there's, you can use a lot more telemetry and data. You can take a lot more approaches to AI/ML than historically maybe you've been able to. That goes to improving threat detection in general. We start to get into autonomously responding to threats. Clearly, that's also where you start to overlap with what we're seeing from an agent perspective. Gets into accelerating threat investigation, automated remediation and recovery, reducing alert fatigue, and then phishing attack simulation being one of the questions they asked, but probably a smaller piece of the pie. What surprised us a little bit here is this: reducing alert volume fatigue. We see that as a much larger problem at our clients today, and so surprised that that wasn't right up in the front, because that's the pain a lot of our clients have. So they're running their SOC. They're not having any issues generating incidents or alerts. They're having issues triaging and responding to those alerts and tackling them within SLAs, because the volume is simply too high, number of false positives are too high, et cetera. And again, that's where data is going to be the only thing that allows us to sort of change that game along with AI. So we think about what we're going to try and achieve. There is sort of a kind of a hierarchy of needs, right? So to do AI in an advanced fashion, you have to have the data to do it. Your AI is only as good as your data. Like, I can't sort of express that point enough. A lot of our clients that we work with will go in and say they have use cases they want to go after, et cetera, and then you ask the question, well, where's your data to allow that use case to be addressed? They don't know, or it's not available, or it's in 3 different systems, or 5 different systems, or 10 different systems, and they don't have a way to pull it all together, make it accessible, and make it available in a format that you can repeatedly build off of it, right? So that's why this becomes so important. And I'll turn it over to Chris to talk a little bit about the slide.
Yeah, no, thanks, Kieran. Yeah, to echo a couple of the things that Kieran just mentioned, right? Like, and I'm sure that many of you can attest to this, that a lot of our clients and a lot of folks within the industry are very much focused on the tip of the pyramid, right? They want to be able to build AI, implement AI. They think that AI is going to solve all their problems. And based on the prior slide that Kieran just went through, I think that there's a lot of support for that comment, right? A lot of people are very bullish on the fact that AI are really going to help us solve a lot of the problems that we're having now by way of its power to assess, its power to extract sentiment from various vast amounts of data, its ability to help with solving a lot of these problems that have been so foundational to cybersecurity. I think a lot of people, at least a lot of people outside of cybersecurity, perhaps don't realize the amount of effort and the amount of coordination that takes in order to get to a point where you actually are implementing AI. And that includes, some of these layers down here in the bottom of this pyramid, which is really circulates around the ability to put together a data system that will allow you to collect data on an ongoing basis, to do that in a fashion so that you can handle the vast amounts and volumes of data that cybersecurity solutions and telemetry producing solutions are throwing on a daily basis. And this is in the hundreds to multi-hundreds of terabytes a day for just your average size corporation. Some larger corporations, you can start going into petabyte scale with regards to the amount of data that's being collected on a daily basis in order to serve all of the mission that a lot of these cyber organizations are now demanding of the data within their agencies and organizations. And I say that people outside of cybersecurity may not have an appreciation for this, because I know that within cybersecurity, at least anybody who's worked in a SOC can probably attest to the fact that we have been laser focused on trying to solve the big data problem in cybersecurity for a long, long time. And that starts off with your log management systems of a couple decades ago to your SIEM systems. And now, new technologies and new approaches are now coming in vogue that take a lot of the sentiment of what you show here on this diagram, and it takes it to another level. And you're talking about some of these new age SIEMs that have data lakes built into them, as well as like these standalone data and analytics platforms that we're going to talk about. And so a lot of the things that we see in the market are, clients really interested in being able to get the power of AI, but not really understanding the work that goes into building the foundational elements below that. We used this diagram here because it's a pretty standard diagram. Anybody who's a data scientist has probably seen this on the open internet, the AI hierarchy of needs. I really like this diagram because it can really apply to a number of different domains and spaces, and cybersecurity is surely one of them. Again, as I mentioned before, like some folks in our organizations can make an entire career out of building these data transit systems, these brokering capabilities, and ultimately being able to get to a point where you can store and manage all of the data that goes into the various use cases that organizations are now demanding of these data. And so we're going to go into a little bit on both ends of the pyramid. So we're going to talk a little bit about what we're seeing in the industry and how organizations are kind of starting to fight this big data problem with the use of modern technologies such as Databricks, as well as building in some of the capabilities that we're seeing on top of Databricks in order to start serving more complicated AI problems. So we just wanted to start off with just a basic diagram of what your traditional SIEM system is. And for those of you who are not in cybersecurity, this just shows, what we call the security event to insight pipeline. Meaning, at one end of the pipeline, you see all of these different data-producing agents, endpoints, edge solutions. These are all of the tools that are either producing an event that some sort of digital activity is happening, or it is producing some sort of an alert to give somebody a trigger to say, look, there might be something here that you'd want to take a look at. Traditional SIEM systems have always brought that data through a standardized pipeline, which you can see here represented here by all these multicolored arrows, and it brings into a data repository. Now, the reason why we represented this as a closed pipe as opposed to something more open is that a lot of traditional SIEM systems operate just as that. They're these closed systems. You bring the data in. It's really hard to get the data back out. And if you do want to bring the data back out, you have to kind of reformat it so that you can use it for a different purpose. And so a lot of the traditional analytics that are being built within SIEM systems, and a lot of SIEM systems have spent decades putting together really curated cybersecurity workflows for detection and response and remediation. Most of that content stays within the SIEM system, and it's really difficult to bring in outside content into traditional SIEM systems, and it's really difficult to be able to democratize that data outside of people who are just working in security operations. And so we see that as a big limitation to SIEM systems, especially as cybersecurity organizations and other adjacent risk capabilities and risk organizations within your enterprise really see the value of this rich telemetry and really trying to use this in order to build additional analytics use cases to include artificial intelligence use cases. And so,
Chris, just a couple of points to add there. So certainly storage costs within the SIEM has been a challenge. I don't know how many folks have been challenged by the CFO or someone else as to why they're paying so much for storage. That's certainly been a topic in the last few years. And then the other issue is performance, right? And even if you have the budget, if you start shoving all the data in there, it's just not built to be that kind of platform, right? It is intent to serve a purpose. It's not meant to be a general data platform in most cases.
No, it's a great point, Karen, and that's actually a good segue to the next slide where we introduce the concept of a data lake. And A data lake is not a new concept. It's a term that's been around for quite some time. Cybersecurity is starting to adopt the use of data lakes more and more in order to help service some of these data management issues and data analytics issues that Kieran had just mentioned. So one, low-cost storage, right? SIEM systems, more and more, as they continue to build in a lot of these really intricate workflows and a lot of this content, which is really good content across these platforms that really hone in on key cybersecurity problems and issues that organizations need to continue to monitor on an ongoing basis. The cost to store data in these SIEM systems is becoming, really cost prohibitive. And it's getting to the point where there's so much data and organizations are using SIEM systems in order to store this data that it's not being cost competitive at all. And it's really causing an issue because a lot of these SIEM systems just can't handle the capacity of data that's required.
Chris, just to jump in real quick. So number one, we get called basically for, family guidance services, right? So someone wants divorced from their SIEM and they're like, hey, this isn't working and blah, blah, blah. But you find out a lot of the issues are not necessarily the SIEM, it's the underlying process and approach that they're built on that is now no longer serving the organization very well. I'm just curious out of the crowd, for those who know or have a perspective, how many of you feel like the SIEM in your environment is being used in a sort of an optimal way? Okay, just for the record, no one raised their hand. So either nobody's involved or this is probably a fairly common experience, right? The other thing I'll mention is that as you get kind of more advanced in understanding the threats targeting your organization, every business is different. So a single product is not going to meet the needs of a very diverse set of businesses in this room, different geographies, different delivery channels. I mean, it gets very nuanced. And so if you want to start looking at identity data, comparing that to what's happening over your IoT network and comparing that to transactions that are going through, you're going to have to do that on your own because no one is building that use case for you, right? So an important point.
Yeah, no, absolutely. And, a lot of SIEM systems are continuing to expand to include other risk domains just outside of the security operations system, which is where many SIEMs have been targeted, a lot of their capabilities. But they're not really keeping pace with, again, the way that data is increasing within the organization and a lot of the demands that are now being put on those data. We'll get to there in a second, but there's a number of different implementation patterns that we're seeing in the market, some of which are very much directly tied to a phenomenon that we're seeing in the market where the SIEM systems are now building data lakes directly into their SIEM platforms, which I think is a positive thing. But by and large, the traditional SIEM system, which is more or less in the architecture that we just showed a moment ago, have some limitations with regards to the capabilities by way that it has to store the data, to present the data to other users outside of the SIEM, stakeholders themselves, as well as being able to adopt some of the more leading approaches, particularly as it relates to machine learning and artificial intelligence, to be able to build those in and apply those seamlessly on the data in the SIEM system.
Again, Chris, sorry to keep interrupting, but you're facing the other way, so I can't. I'm about to hit you. There you go. So again, a couple of points to add. So curious out of the folks in the room who raised their hand for data science, how many of you work on cyber specifically? Or do you specifically work on cyber use cases, or are you doing broader, right? So I think 2 people raised their hand out of that group. That drives the point home that the data scientists in your organization aren't on loan to the cyber team, right? So if you're picking your own path and you're trying to build something on your own, that's great, but you're going to be limited to resources who know your SIEM platform, right? If you tag on with something that's bigger, probably footprint in the organization that's generally being used for data science, you likely have greater pull-through as a cyber organization to get help from others, as well as integrate to what they're doing across IT in general. And so again, I think that's important because historically cyber sort of, and I've been in cyber for a long time, so I point the finger at myself. We've run off and we had our own toys. Right? Nobody gets to touch our toys. They're our toys, and it's too secret, and you can't touch it. But that doesn't actually work well in the data science world.
No, that's a great point. And I think that this represents a convergence that we're seeing more widely in the market where a lot of the data science tools and capabilities are now converging with cybersecurity tools and capabilities. As Kieran mentioned, as SIEM systems have grown and evolved, they've kind of done so in the image of the people using them, right? So these are the security practitioners, the network engineers, those that ultimately worked in the security operations center. And with that, they spawned their own languages, their own syntax, their own data models and schemas, right? Very unique to the tradecraft and very unique to the domain. As Kieran mentioned just a moment ago, a lot of what we're seeing now is a lot of these general data science, data management practices and principles, things that kids are learning in college now are now being applied to this domain. And so you're seeing now these really performant data systems like Databricks that will allow somebody to come in with just general knowledge of standard SQL and Python and can really be really effective and impactful building out security use cases, building out code that would serve security problems. And with that, as we continue to progress in our conversation, some of the things that we want to talk about specifically is how Databricks is now covering down on a lot of the capabilities that we're seeing lacking in a lot of the traditional SIEMs. So the ability to bring in like I said, a general purpose data system that provides the tools and the capabilities to build out more advanced use cases. That gives you the ability to store volumes of data at a far lower cost than you would in a traditional SIEM system and have more ready access to those data with more traditional data science tools that you're seeing more openly adopted in the market. Also seeing the ability to basically proliferate the data across the organization. So not only can you use tools that are directly connected to Databricks and those that are in the Databricks ecosystem, but you also now have the ability to connect the data to other tools, many of them being like your traditional cybersecurity tools, like a SIEM. So we're seeing a whole lot of flexibility now being opened up with the advent of the data lake and some of the capabilities that are now being offered on these platforms. And so with that, we'll take you to the next slide. I mentioned this a moment ago, but trends that we're seeing in the market. So as we think of Databricks as your cybersecurity data lake capability, we're seeing our clients adopt them in a couple of different patterns. The first one that I'll speak about is on the very far left, which we call the bolt-on model. And so this is it really, as it shows in the picture, an organization has a SIEM. They are looking for a way to relieve cost pressures and a way to store the vast amounts of data in a different, low-cost, high-volume array. And so they're adopting data lakes like Databricks, and they're basically just dropping the data out of the back of their SIEM, and they're putting it in a data lake. Now, there's both pros and cons to this solution, one of which the pro is that it doesn't really disrupt the data pipeline that you have in place and all of the other technical debt that you've built up around the SIEM, around the data pipelines and the data acquisition scripting and things like that. And really what it does is it just bolts on a storage array to the bottom of the SIEM. What you lose in this particular case sometimes is that you're not able to maintain parity between the SIEM and the data lake, and you're not really able to use a lot of the data that's going into the data lake, because oftentimes that data is getting stored into the data lake in some sort of proprietary file format that doesn't allow like a lot of your general purpose tools to access and analyze the data. With that, we are seeing now the second model come about, which is what we're calling the parallel pipeline. So in this model, you see here that data is being pushed directly into your SIEM to run your cybersecurity workloads as you normally would, to use all the different logic and all the different workflows and things like that. And then you have Databricks or a data lake ingesting either a parallel data set or some derivative data set so that you can bring that down in there. And oftentimes we're seeing that the data that's going directly in the SIEM gets very much pared down to only those data that are required to execute the alerts, to run some of the workflows, and to do some of the analysis that security operations folks generally need, which generally consists of having data somewhere in the neighborhood of like 30 to 90 days old, very specific to certain trends, alerts, and notables. The rest of the data goes into a data lake or into Databricks, where your security data science team, some of your other researchers can then use that data in order to explore the data further, to build out other use cases, or in the case of incident response, you can have an incident response team have access to all of the data to include all of the raw logs so that they can parse through that data. That's the second model. Again, the pros is you're able to scale back the data that's going into the SIEM, so you don't have to bring all of your data into your SIEM. And with a lot of the pricing models that are out there with SIEMs, you get charged for the data that actually comes into the SIEM, whether it be the actual data that gets pushed into the SIEM or how you process that data to normalize it against some sort of schema once it gets in there. Instead, you can only bring the data in there that you really need. You can bring the rest of that data into a solution like Databricks and you can manage it there. The cons are is that it includes some sort of duplication of data, right? So as the picture represents, you're bringing at least some version of both data streams into both the SIEM and the data lake so that you can use them in parallel. So with this phenomena, we're seeing the newest pattern emerge, right? And this is what we're calling the subscriber model. And I think that this is more, at least at present, this is the modern architecture that we're seeing that can really help with expanding the use of the data, not only for the SIEM system, but also the ability to continue to use that data for other capabilities outside of the SIEM. And so what it does is it really effectively separates the data management capacity of a SIEM system to the actual data and analytics workflows. And it keeps them separate so that you manage all of the data in a central data lake capacity, and then you can use the SIEM in order to run the analytics workflows that SIEMs come with either out of box or that you can program into them.
So Chris, I would just jump in, make a couple of points. So in the last scenario, chances are if you do start to get into more advanced use cases, leveraging AI and start building agents and so forth, they're going to have to consume from a data lake as opposed to from a SIEM, right? Or similar technology in that case. So in our case, we run multiple flavors of security operations centers for our clients. And so because we're running, across multiple clients, we don't have a single, and they're not all using the same tech. So we don't have a single system that they're all using and touching. So we have to build and operate a level above that, right? So we have to collect telemetry from all of the systems deployed within client environments, bring them in and up level it to a standardized approach across all of them so that we can obviously execute in a standardized way and do so efficiently. So if you're in a large organization, if you have multiple divisions and you've got different tech teams out there, et cetera, you might be in a similar circumstance. So again, the data lake model might be the smarter way to approach it.
Yeah, no, agree. And to Kieran's point, I think that the subscriber model that you're seeing right here is definitely aligned with where organizations are starting to build out their agentic AI ecosystems, right? And really being able to use a data lake to manage the data, manage the access to the data, and then have a lot of these agent-based systems and ecosystems just pulling the data directly from.
Everyone's got to do a shot every time they word the word agentic.
That's right.
Yeah.
We wouldn't be here, right? We wouldn't be here if it wasn't for that. And so this diagram right here kind of represents that concept of the subscriber model. And so again, using the security event to insight pipeline like we use to illustrate the traditional SIEM model, we're showing here now the idea of this separation between the data system, the underlying data system, which you can see there in the middle, built from Databricks, from all of the different consumers of those data, which would include, up here in the top, a SIEM system, could also include a SOAR, a case management system. We have down here this SPCL, our specialized tools. So say if you have a fusion center and you have folks that are doing fraud management, if you have other folks doing compliance, if there's other things that are being done around supply chain management, these are all tools that can consume data directly from the data lake. And then also to Kieran's point just a moment ago, we have this represented in a different color because we're trying to represent some of the capabilities that are available on the Databricks platform, but this also includes the ability to build and develop and serve AI models using the data lake as the storage repository to pull those data from. In this particular representation, as you can see here on Databricks, we're using the Unity catalog in order to manage the schema, in order to manage the data. Delta Lake is the storage array, again, based on your hyperscaler of choice. And then, for those of you that are familiar with Databricks, and I assume everybody is here, we're at the conference, leveraging the various storage levels in order to build out your raw log storage capacity, some of your parsed and normalized as you start applying data models on top of it, and it can be multiple data models. Everybody understands that a lot of these SIEM systems have their own proprietary data models, and if you want to use more than one SIEM system or if you want to use more than one system, the data lake allows you to develop multiple different data models and integrate them. And then the curated and structured data sets are really those data sets like feature vectors that are used for building out and running machine learning models and things like that. So being able to have those built in there as well, all in the same capacity, and then use various methods in order to establish what we call like a data and AI fabric to ensure that those data can be shared back and forth between the solution systems, back and forth again.
Yeah, occasionally we get the question of like, well, who keeps raw logs anymore? The answer is like, if you're not, you should be, because there's basically a lot of context that's lost as you go up that chain. And in many cases, you're going to find that what's lost is important for an AI use case. And so, storing the data in multiple ways is also a key strategy, because if you summarize, you lose fidelity, right, in many cases. And so that's going to be, probably an ongoing need.
I mean, for cybersecurity, the mantra, way back in the day is we want to keep everything. And then we started running into storage capacity issues, and they were like, well, maybe we can't keep everything. And now that a lot of these capabilities and the storage is becoming cheaper, we're now getting back to the state where, well, maybe we can keep everything just in case we need it. And again, I don't know about you, Kieran, but as we continue to push forward in AI, we continue to uncover new ideas for use cases to use data that we've, hadn't used previously. So being able to maintain those data and keep those data, not just for compliance reasons, but also for, research and development reasons, has become very, very impactful. One thing we did want to double click on just a little bit, and again, this is one of the things that, needs to be explained a little bit as you start building out that subscriber model with a SIEM system, right? And I think, many people within this room kind of understand some of the data sharing capabilities within the Databricks platform, right? If you wanted to be able to run, organization that has multiple different Databricks installations across multiple clouds and using a lot of the integrated features right there. This diagram right here shows an integrated data mesh between a Databricks platform and a commercial SIEM system, right? Which all the time, they don't necessarily sit in the same cloud. One might be on-prem. Your Databricks installation will be able to communicate with that via this, what we're calling the data and AI mesh. And again, you can do so in a couple of different ways. Dependent on the SIEM system, right? You can connect it using APIs, other various connectors. I think folks are familiar with Lakehouse Federation as a sharing service, and Delta Share as another sharing service between Data Lake and some of the other solutions. So Databricks is making it very easy to democratize data to other platforms that are not natively sitting on Databricks. And within a traditional SIEM system, really a lot of the capabilities that are required is can you search the data from your SIEM system to somewhere else? And so that brings about this capability of federated search there in the middle. Below that, there is principles of being able to share the data back and forth between the two platforms, right? Because remember, SIEM systems also have their own onboard storage facility that it uses, and some of those use cases that you would want to execute, or some of the research that you might want to do it directly in your SIEM system. So, but having a data sharing and ETL capability from between Databricks and your SIEM systems gives you the ability to bidirectionally share the data back and forth between the onboard data repository within a SIEM system and then Databricks. And then lastly, some of the emerging capabilities that are coming that draw more parity between the SIEM system and the data lake, and in this case Databricks, is being able to do federated analytics. So do I have a model, do I have some code that I want to initiate in my SIEM system and execute in Databricks? And so those are three different scenarios for which you can really draw a really tight connection and build what this AI and data mesh between your traditional SIEM system and Databricks.
Yeah, and I know we're talking about SIEM because that's kind of the center of the SOC and a lot of focus from a cyber and an analytics perspective. I do want to point out, though, it's not just about SIEM. There's a ton of data, for example, in your identity management systems, right? A tremendous amount of data, a lot of value. Historically, we've not seen clients integrate that into the SIEM because of some of the challenges we've talked about already. And so really this is setting you up to start expanding into other data domains that can make you more effective and allow you get to some of the things we talked about in the beginning in terms of better threat identification and better response time and so forth.
Thanks, Karen. Yeah, and before we open it up to questions, we're going to share one more slide with you guys, and kind of continuing to persist this idea of drawing the integration between your SIEM system and Databricks, this next diagram illustrates how the Databricks data management system, and again, we've summarized the security event pipeline here to just show data management, serving, and insight consumption. But you can see here that Databricks can be used to manage the data, help with serving the various data needs in order to run a lot of the onboard analytics that you traditionally find within a SIEM system, but also gives you the ability to build your custom AI models. And in this particular picture, it's the model itself is scoring data in a production environment and sending those insights by way of a score or a range or a rank, and it sends it back into the SIEM system, it sends it back into Databricks so that it can ultimately be consumed by the SIEM system and integrated with the various workflows that would require it. And you can see here that definitely continues to serve the Security Operations Center. The models themselves can serve, security data science teams, research, but then again also, and again, through some of the work that we do, we've built out various models that would, execute use cases that we just couldn't find a way to do so in the SIEM, because the SIEM was either not able to process the amount of data that we needed, or it didn't have a capability such as like access to a deep learning algorithm or something like that in the SIEM itself. So we would do that work in the data lake, send the insights back into the storage array, and then ultimately reconsume that into the index.